Today's lecture is on context-free grammar. As I told you, so grammar for a particular language, we can say it is defined as a finite set of formal rules for generating syntactically correct sentences. The language may be a formal programming language like such as C, C++, Java, Python, R, or any spoken language or natural language such as English, Hindi, Marathi, French. So any type of language, it requires a grammar, and this grammar basically defines syntactically correct statement format or the construction of that statement, uh, which is allowed for that particular language. And hence we can call a grammar for a language as a syntactic definition of a language. So you can say grammar is nothing but the syntactic definition for of a language. And like so basically the grammar for any natural language or for computer language, it is nothing but the set of rules, and it will and with the help of those rules you can identify whether the statement is syntactically correct or not. So for example, if you could say, if you have an English statement, dog runs, so we can write here basically this dog runs is what? It is nothing but a sentence, and this sentence, it comprises noun and after that the verb. So in this noun and verb, so this dog, it is your noun, and runs, it is your verb. So whether this statement is syntactically correct or not, as per the English rule, whether the framing of this dog runs, this particular statement is, whether it is grammatically correct or not, that can be tested with the help of grammar, English grammar. And the English grammar says that you can have a noun and after that there should be a verb. So if we will follow, if we will apply that rule, so then dog runs, it is a syntactically correct statement. So it is a grammar which tells whether the statement framing is grammatically or syntactically correct or not. So any grammar, it has two types, terminals and non-terminals. So your grammar is basically, it comprises of two types of symbols, terminals and non-terminals. And formal definition for a grammar, you can see here. So the context-free grammar is defined with the help of four tuples. It is VTSP. So here V, it means it is a finite set of non-terminal symbols, which are, you can say, placeholders, and which can be later expanded to generate a set of strings. So these non-terminals are also known as a variables, and usually the capital alphabets are used to represent the non-terminals. Then T is nothing but a set of terminals, and for that, for the representation of terminals, usually the small alphabets digits are used, and it is nothing but the string, and this string will have these symbols, small alphabets and digits, and it won't get expanded later. Like as I told, for non-terminals, it can, we need to expand the non-terminals to get a set of terminals. So likewise, the terminals will never get expanded. Then P, it is nothing but a set of production rules. So basically, when you talk about the syntax of any particular language, so that syntax or that rule, the syntax, you know, it basically, it tells whether the statement is framed correctly or not for a particular language. So that syntax or the rule or that information you can specify in this P. So we can say P is nothing but the production's rule. So so you can say here this production rule, it can have the terminals and non-terminals. It will be the combination of all. So production rule, it can be specified in this form, some non-terminal, then you will be having an arrow, and here you can have a sentential form on the right hand side of the arrow. Sentential form, it can be the combination of terminals and non-terminals. Sometimes on the right hand side of production rule, you can have only terminals. So that is also possible. And usually capital S, it is basically used for the start symbol. So you can say this is a special type of non-terminal symbol. So when you want to define your uh, language grammar, if you want to design some new compiler or new programming language, if you want to design, so very first thought that should come in your mind is what are the different symbols you are allowing in that grammar, in that language. So all those symbols you should put it here in the T. So all those will be your set of terminals. Then you should talk about the non-terminals. What are the different non-terminals you will be having? So yes, you will be having the variable. So variable can be your one non-terminal, because for designing of variable, you need to specify the rule which particular set of which particular string will be the valid variable. So that variable, if I'll say, if we'll take the example of C language, if I'll say max, so max is a valid variable name. So on what basis I can say? Because in C language production rule, uh, this max, it is allowed. It is following all the variable rules specified for C, as it is not starting with the digit. It does not contain any special symbol. It can start with alphabet or underscore. So if I'll apply that rule, yes, it is, though it is not starting with underscore, but it is starting with alphabet. And after the underscore or a alphabet, later I can have any combination of digits and alphabets. This is what is these are what rules for the valid variable name. So that rule you can specify here in the production rule, and with the help of regular expressions, you can take the help of regular expression here. And finally, whatever string you will get as a variable, that will contain those symbols which are there in the T, right? So your actual variable name will have the set of symbols which are there in the T and which are allowed by the uh, rules, rule for designing the variable. Then you should have a rule for a valid integer. So whatever collection of digits you are having, whether that is valid or not, that you can decide with the help of rules for a valid integer. And finally, whatever number you will get, it will comprise of the symbols which are there in the T. So definitely 0 to 9, those symbols must be present in the T. If out of 0 to 9, if any one symbol is not there, for example, just imagine if 4 is not allowed. So it means your any number, any constant, any float number that will not, your programming language will not accept that number with 4. So that is the reason when you will design your compiler, you should think on these things first, that what will be your non-terminals, what will be your terminals. You should think about the symbols first, then you should think about the rules. Rules for variables, rules for float value, float constant, rule for integer constant, then keywords, which keywords you are allowing, that you need to think. Then how your arithmetic statements will be allowed, how what will be the rules for a if statement, what are different types of loops you are allowing, and what symbols that syntax of that loop will have. So that all those things, all those rules you will be specifying in P. So before actually you will start writing your compiler, you need to think on these things. You need to do this paperwork first. You need to do this brainstorming first. Once you are done with the P, then major part of your compiler designing will be done, because okay. So these are the things which you should remember or you should think of when you will design your own language, right? Then notation for the context-free language. So non-terminals denoted by capital letters or alphabets. For example, this I told you earlier. Terminals, it will have uh, the symbols which you can see, all small alphabets, digits, and any other symbols if you want to include that you can specify. Then string of terminals, it can be represented with the help of this U, V, W, X, Y, Z. Sentential form, it can be represented with the help of alpha, beta, gamma. So sentential form, it is basically the combination of terminals and non-terminals. This you should remember. So whenever I'll say sentential form, it means it is a combination of terminals and a non-terminal. So if in this fifth, you can see it is what alpha produces beta. So this is a very generic form of production. So this type of usually we will be having the arrow and there will be something on the left hand side and there will be something on the right hand side. So when you are putting anything in this form, you can say it is nothing but a generic form of production. But when it is a context-free grammar's production rule, then on the left-hand side of the arrow, there must be or there will only be non-terminal. For a context-free grammar, on the left-hand side of production, there will be only one non-terminal. And on right side of the arrow, you will have there will be a sentential form. So in the seventh case or point, you can see E produces. Here this arrow, how you can read this? You can read it as a produces. Or so E produces E plus E or E star E or ID. So here basically you have three productions or three production rules. This is used for specifying the arithmetic statement. But it is having only two operators for two operators, plus and asterisk. So E produces E plus E or E produces E into E or E produces ID. So these three production rules are here, but because the only one non-terminal we have, which are having all these alternative production rules, and that is the reason you can combine it together and you can put or sign here. So it means E produces E plus E, E produces E into E, and E produces ID. So, and here this is a context-free grammar's production rule, we can say. Why? Because on left hand side, there is only one non-terminal, whereas on the right hand side, you are having a sentential form. So sentential form, as I said, it will be the combination of terminals and non-terminals. So this E is a non-terminal and plus this is a symbol which is a terminal. So same is the case with E into E, and ID it is a terminal only. So that is the reason on the right hand side you have sentential form, on the left hand side you have only one non-terminal, and that is the reason it is called as a context-free grammar. So this can also be written in this way. E produces EAE or ID, and this A, it can be expanded to plus, minus, multiplication, division. So if A get replaced with plus, so what you will get? E produces E plus E. Or if A get replaced with I, and the next alternative production for A is minus. So here this A will get expanded to minus. So you will get E produces E minus E. Now, if you consider the third production rule of A, so A produces asterisk. So here this A get expanded to asterisk. So you will get E produces E asterisk E. And similarly for slash. And E produces ID, it is there. So this is how it will work. So this is the example of production.
Ma'am, are you sharing the screen, ma'am?
Sorry?
Ma'am, are you sharing the screen?
Huh, yes. Is it, it is not visible or what?
No, no, ma'am.
Now is it visible?
Yes, ma'am.
Till this it was there in front of your screen, right?
Yes, ma'am.
And this part? Okay, so I'll repeat it again. See, as I said, non-terminal, it comprises of capital alphabet. Terminals, it will have all the symbols. So, and usually terminals will have the small alphabets, digits, then any other symbols like asterisk if you are using, plus, minus, multiplication, division, symbol for division, symbol for modulo, then hash, at, semicolon, comma, double quote, single quote, that everything will be there, parentheses, curly braces, everything will be the part of terminal. So this T, it is nothing but a set of symbols which you want to use in your programming language. Then string of terminals can be represented with the help of this small alphabets U, V, W, X, Y, Z. Sentential form it will be the combination of terminals or terminals and non-terminals. So both you can say it is a sentential form. Then it will be a string, and the string will consist of terminals, or string can have the combination of both terminals and non-terminals. So fifth point here, A produces beta. This is a very generic form of production. Then A produces beta. So this type of production, it is called as a context-free grammar. Why? Because on left hand side of this production rule, you have a non-terminal, and on right hand side of a production rule, you have sentential form. So sentential form will be a string, and that will be a combination of terminals and non-terminals. So when such type of production rule you have, we call it as a context-free grammar. So remember this, context-free grammar will have only one non-terminal on left-hand side of production, and right-hand side will have the sentential form. Whenever I'll say sentential form, it is a combination of terminals and non-terminals, or sometimes it is terminals only. That means it will be a string. Then 7 point here, it is an example of context-free grammar. E produces E plus E, or E produces E into E, or E produces ID. You can write it in three different statements, or because it is a common non-terminal which has these three alternatives, so you can combine it in this way also. So E produces E plus E, or E produces E into E, or E produces ID. Then you can write the same production rule which is there in point 7 in this way. So E produces EAE or ID. So this A, it will get later expanded to plus, minus, multiplication and division. So as when E is when A produces plus, if we'll consider this first production rule, E A produces plus, then in this case that A will get expanded to plus and you will get E produces E plus E. When E produces minus, that time this A, it will get expanded to minus and you will get E produces E minus E. When A get expanded to asterisk, you will get E produces E asterisk E. When A get expanded to slash, that is division sign, you will get E produces E slash E. And the fifth production for E will be E produces ID. So this way you can write the rule. So basically this grammar, it is for designing or framing arithmetic statements. These are the example of context-free grammar. So, or of productions, you can see if you want to say what is digit. So digit is from 0 to 9. So this is or sign is used, 0 or 1 or 2 or 3 or 9. So your digit will have anything from 0 to 9. Then actually digit, you can say here there should be at least minimum one digit you will be having in your integer and float constant. So that we'll see. So digit, when we say, it will have a symbols from 0 to 9. When it is a sign, so sign can be a plus or it can be a minus or it is epsilon. Why epsilon? Because sometimes we don't give a sign to any constant. It can be integer constant or float constant. So when you are not giving a sign, it by default it is plus. So uh, sometimes explicitly you are giving, sometimes you are not giving. So that is a reason for to show empty sign, it is epsilon is used. Now integer. So how you will define the integer? So there will be a sign, then there will be a digit, and after there will be the occurrence of 0 or more number of digits. So when any constant, if it follows this rule, we will say yes, this is the valid integer for a language. Now for a float, the rule is it can be in either plus, minus or no sign. Then there will be the integer, then dot symbol, then there will be the integer. In some cases, E is also used to show the exponentiation. So accordingly, you can change this rule. You can have one more alternative to indicate your float constant, where it will have the exponentiation part also. Sometimes you have this 10.4 E plus 2. So this is also another way of representing float number. So if you are allowing this representation of float number in your programming language, then here this production rule should have that part also. Like here you can have sign, then integer, dot, integer, then there will be a capital E, then there will be a plus, and then again there will be integer. So that another alternative which is another representation of float constant, you should specify.